All right, hey, this is pre-calculus week 2. All right, you did calculus and SAT prep, so we're going to do pre-calc now. And if you ever find that something is easy, then you could just jump up to the calculus section, because that is what you're going to learn in pre-calc. So I really should change these to getting ready for pre-calc, like it says in the Khan Academy book. It's all right. So the first thing this week is all about polynomials. So let's get started. We are going to subtract one from the other. And so we are going to subtract this from that. So we want to do p squared minus 5p plus 4. Subtract 4p squared minus 9p plus 11. And as a pre-calc student, I always think it's a good idea to rewrite it and then just distribute that negative to all three. So minus 4p squared plus 9p minus 11. And then we, of course, combine our like terms. So I'm going to give each pair their underlines there. So we got p squared minus 4p squared. That's going to be negative 3p squared. We got negative 5p and adding 9, so negative 5 plus 4. And then 4, and then the negative 11 was that. That becomes negative 8, negative 7. All right, and so you want to be able to do this kind of stuff. Kind of like that, I wouldn't rush through it so quickly with Algebra 1 students, but that's when you learn Algebra 1, and so now you just need to use it, right? Okay, so this is the same sort of things. I'll let you do that. Moving on, again, the same sort of thing, you can do that. Oh, wow, all right, so that was easy, switch the signs on the second expression and combine your like terms. You can do it. I know you can. Okay, so now let's talk about multiplying. And then the other thing is, you may hopefully think that this is kind of easy stuff. And so definitely run through it, prove that you can do it, and then jump over to the getting ready for calculus material and take a shot at that, and that'll be more along the lines of not just what you need to know for what you're learning, but what you are learning. Okay, so negative 2y squared and y squared is going to be negative 2y to the 4th. Negative 2y squared times 6 is negative 12y squared. This box, y squared times 7, 7y squared. 7 times 6 is 42. So just in case I didn't teach you really fast, this is how I set up my multiplication problems. I draw the Punnett square, the box is there, and then I put one equation on the top, one equation on the side, and then fill it in as I did by multiplying. The last step is to combine the like terms. So if you look there, we got 7 minus 12 is negative 5y squared. And so now I'm just going to write all the terms together. So it'd be negative 2y to the 4th, bring down the negative 5y squared, and then the 42 will be a plus 42 at that. Does that make sense? Negative 2y to the 4th minus 5y squared. So hopefully you're feeling really confident so far, because this is, you did this in Algebra 2. I know it. And so we can, do that. This one, I'm not going to do it all the way through. I'm just going to say that make sure you understand that it would be 2a to the 6th minus 6a to the 3rd times 2a to the 6th minus 6a to the 3rd, right? The exponent of 2 means to write it twice, and then do your thing. Draw the boxes, or FOIL as some people do. I don't FOIL. All right. I stopped FOILing years ago. In this one, see if you use the box method that I do, and for this one, you would just draw a 2 by 3, and then it works just fine. So I'll put the k squared minus 5k minus 2, and then the k squared and the 2, fill it in, combine the like terms. All right, so give that a try. All right. Those are some tips and tricks for quiz 2. You can probably also see why we do 4 quizzes. Yay, factor. Okay, so definitely have to do the multiplying before the factoring, right? And now we factor, and it's not your algebra 1 factoring because we have the a coefficient bigger than 1. It's a lot bigger than 1. But as I look at all 3 of these, I notice, and I hope you do too, that they are all perfect squares. And that means two numbers, the same two numbers multiplied together to give you those numbers, right? Yeah, 144 is 12 times 12. So I'm thinking if we had 2 9s, that would be 81. So 9p and 9p. And then that would be 8q. And then there's a minus in the middle, and 2 negatives multiply to a positive, so they must both be negative, and then they multiply to the positive. So I think this is 9p, 9p minus 8q, and it's the same thing twice, squared, like that. Okay. So here we want to plot all the zeros on this interactive graph. And so I already see that 1 0 is at 2 because we have x minus 2. But this guy needs to be factored to x squared minus 9x plus 7. In order to factor that, I am going to use my favorite factoring method called slide and divide. Because I see that the a coefficient is bigger than 1. So I'm going to take that a coefficient and slide it over to the 7 by multiplying. So it's going to become x squared minus 9x plus 7 times 2 is 14. That's called slide. 2 times 7. And now I factor. So now I'm going to factor this. I see that 2 and 7 multiply to 14 and add to 9. If they're both negative, they will add to negative 9. So slide, factor, divide. And so what do we divide by? We divide by what we slide by. So we slid the 2, so now we divide both these numbers by 2, and we get x minus 1. And then 7 does not divide by 2, so we bump the All right, nice little tool there. Now we can see all the zeros of the polynomial. This guy, let's bring it down in front. All right, so now we got the zeros. We got 2 is a 0, 1 is a 0, and 7 over 2, that's 3.5, right? So 3.5 is a 0. It's another thing. Pre-calculus, calculus students should not be scratching their heads about fractions. 7 halves, used to say, oh, that's 3.5. Shouldn't say, oh, I need my calculator. I don't know what that could be. All right, and then this is 2 terms. And again, 16 and 49 are both perfect squares. This is what's called a difference of 2 squares. And so hopefully you remember that. We just take the square root of both terms and we write it's a binomial. Then we write it again, but this time with a minus. Do you remember that? I hope so. All right, so this quiz is better than the others. Okay, see another different one here. So this one we have to factor, but this time there's how many terms? 4 terms. So whenever there's 4 terms, we want to factor by grouping. We're going to pull out the GCF of both pairs. What's the GCF of the first two? It would be x squared. If we pull that out, if we divide both of them by x squared, then you would get 2x minus 1. The GCF of the second two would be 2, but if I divide both by -2, then I would get -2, and I would get positive 4. Positive, oh yeah. Oh, I mean, I can divide them both by 4. And so then we get positive 2x minus 1. And so why did I pause there? Because I knew when you factor by grouping, you want these inside to be the same so that you can factor those out. And when I had originally divided by 2, it wasn't big enough and it wasn't becoming 2x minus 1. But then I could divide it by 4. So I did. It worked out. 2x minus 1 is in both sets. And then if we take that out, we're left with the x squared minus 2. All right, so what are the zeros? 1/2 for the first one, right? And then for the second one, we got x squared minus 2. So that, you should remember the zero product property. A lot of people, oh, hey, just x minus 2. We don't need to, it's not that serious. Okay, so then it's just, no, it is that serious. It's x squared minus 2. So you need to remember the zero product property. We're setting it equal to 0. We are solving it. And we are even putting a plus minus at the beginning. So I don't know how they want us to plot that. But if we get it wrong, then I will just look and see what I did wrong. The square root of 2 is like, it's about 7. Well, we're gonna have to get help. All right, so let's look and see what it was. Oh, it was 2. So let's look. X plus 2, x minus 2, 2x minus 1. So x squared minus 4. Oh, okay. So I messed it up. I had x squared minus 2, but it was x squared minus 4. Because why? Because it was x squared minus 4. We take out the 4. Oh, whoopsies. I had written the 2 still, but I should have written the 4. And then it would have been x squared minus 4. And that's a difference of 2 squares. You got it? If you don't, then you can just put it in the organizer and I'll explain it to you. Okay, in this last one, you can see a difference of, you can see the squares. So give that a try. All right, and you know what? Sometimes we get things wrong, and that's okay. That better be okay. All right. If it's not okay, what are you gonna do when you get something wrong? Because it's gonna happen, right? All right. So now this one we factored, we added, we multiplied, subtracted, factored, and now we're dividing. Straight up dividing. Your answer should be in the form p of x plus k over x plus 4. We see that x plus 4 is the denominator, where p is a polynomial and k is an integer. So what we're going to do is, we're going to do some long division. You ready? We're going to do synthetic. Two long division. There's 2 types. Long division and synthetic division. You should have learned them both in Algebra 2. Let's start out with long division. On the inside, I'm going to put x squared plus 0x plus 1. Put the 0x because there's no x term in this, but we can't skip a degree. So we got to go 2, 1, and then 0. And then we do our division. Divide x squared on the inside divided by the x is x. That goes up top. Right there. X times x is x squared. X times 4 is 4x. And then we add negative signs in front of both terms. And that is so that the first pair cancels. 0 minus 4 is negative 4. Bring down the 1. And then we do our division again. So now it's the negative 4x and the x. So we go with negative 4x divided by x is negative 4. And that goes up top. And then I multiply. Negative 4 times x is negative 4x. Negative 4 times 4 is negative 16. But then we add the negative signs. They're already there. So that's going to change them to positive signs. And still it works out so that those cancel. And 1 plus 16 is 17. The final answer is x minus 4 plus 17 over x plus 4. So we put our answer on top, and then our remainder is put over the denominator. So let's write that out and verify. You don't think I'm wrong. Okay. So this is going to be the same thing. This time I could do the same thing, but this time I'm going to teach you synthetic division for review with you. You didn't already know it. So x minus 5 is the factor we want to divide by. Then we can set it equal to 0. And then we get 5. It's 5. All right, so that's the first step in synthetic division. Whatever you want to, the factor, you want to, basically put the 0 inside a little box. Then here we're going to, right over here, we're going to line up the coefficients of the polynomial, not forgetting to put a 0 for any missed exponents. So 1, negative 1, and then there's no x squared term, so 0, then negative 21, and then negative 20. Now I draw a line, like an addition line. We're going to bring down the first term, 1, and we're going to multiply. 1 times 5 is 5. Then we add. Then we multiply. 5 times 5 is 25. And we add. That would be 4. Then we multiply. That's 20. And then that's 0. So this last column is a remainder column. And the remainder is 0. Which is great. That means our trinomial, because we have 3 terms, is going to be 1x squared plus 5x plus 4. That's the synthetic division way. Okay, so as a product of linear factors. So, but then as you can see, x squared plus 5x plus 4 is x plus 4x plus 1. And then the factor we divided by. So you see that? I skipped a step there at the end, but hopefully it was a step that you able to follow me through. This factors into x plus 4, x plus 1. You see that? Because 4 times 1 is 4, and 4 plus 1 is 5. All right, you can do that. You can use synthetic division or long division. So I can do that. First one. All right. Should be good to go for week 2. So, and then, post in the organizer, and that's where we'll start.